Hi, today we'll talk about the normal distribution, standard normal distribution, as well as how to use the TI-84 plus normal CDF function. So let's start with the normal distribution. This is a probability distribution function, which is bell-shaped, so it's symmetric. It's centered around the mean, which we'll call mu, and it also has this parameter called standard deviation, which we call sigma, which lets us know how tall or short, in other words, how wide or narrow this bell will appear. The higher the standard deviation, the more the data is spread out, or the more our observations are spread out, the wider this bell will be. There is a specific normal distribution called the standard normal distribution, which has a mean of 0 and a standard deviation of 1. We will often call this distribution the Z distribution. So mean of 0, standard deviation of 1. So how does this normal distribution relate to probabilities? The area under these curves is probability. In other words, this area here between negative 1.2 and positive 2.3 is the same thing as saying what is the probability of observing some value, some z value, between negative 1.2 and positive 2.3. So this area and this probability are the same number. If you want to find this number, find this probability, you can come over here to your TI-84, pick the DISTR, distribution button, and select the normal CDF function. Here, you have some different inputs. What's the lower value you're interested in, the upper value, the mean, the standard deviation. The lower value we're interested in is negative 1.2. The upper value we're interested in is positive 2.3. Since we're talking about z, we're talking about a mean of 0 and a standard deviation of 1. If you have an older calculator, when you select normal CDF, you may just see normal CDF in an open parentheses. That's okay. Just enter the inputs the same way. Enter your lower value that you're interested in, and then a comma, then your upper value, your mean, and your standard deviation, and just use commas to separate them. So the area under the curve between negative 1.2 and positive 2.3 is 0.8742. In other words, this probability here is around 87%, or 0.87. So what do you enter into the calculator if you have a problem that looks like this? What is the probability that z is greater than 1.7? This is very similar to the previous problem. The lower value you're interested in is 1.7. The upper value you're interested in, well, this distribution continues to go to infinity. Your calculator actually understands this symbol as infinity. 1, and then E right here, capital E. And then 99. This represents a 1 followed by 99 zeros. Your calculator says, yeah, that's close enough to infinity. And so this probability is around 0.0446. So around 5%, around 4.5% of the observations lie above 1.7. So how can you use this in an application type problem? Imagine you're some quality control person. You have a machine that fills milk bottles with an average of 32 ounces and a standard deviation of 1.2 ounces. The amount of milk in these milk bottles follows a normal distribution. It's not standard normal, it is just normal. What percentage of the bottles are filled with less than 32 ounces? You can come over here to the normal CDF. You are interested in the percentage of bottles that are filled with less than 32 ounces. So that could be anywhere from negative infinity all the way up to 32 ounces. The mean of this distribution is 32.2. and the standard deviation is 1.2. So the percentage of bottles that are filled with less than 32 ounces is around 43%. So if you're a quality control person, you shouldn't label these bottles as 32-ounce bottles of milk, because around 43% of the time, someone's going to yell at you.